Tech, Information Technology branch, and currently I'm learning React and wanted to work in the field of web development. So today's topic is get behind the scene. Okay, so we will be dealing all the commands from basic to advanced, and there is no prerequisite for attending this topic because we will covering all the commands and see how it's working behind the scene. Okay, so these are the topics which we are going to deal today. Okay, so it will cover all the commands of Git as well and GitHub also. Okay, so let's start without wasting our time with this topic first. Making our project version control. So what is version control? First, I want to explain this. So version control is nothing but it gives the power to control, to store, right? Store or to save the changes that you are making on your project, right? So it is the most powerful software till now because every project, if you see, are hosted on a Git or GitHub, mainly used so that they can able to track those changes that they are doing and can come later on and see those, analyze those changes, right? So we'll first move through some basic command like git init, right? So this is the very first command which we use to initialize a repository in GitHub, in Git. Okay, repository. Okay, let me show you some practical stuff, right? So if you see, I am using this Visual Studio Code, and inside it, I am having a CLI of Git Bash. Okay, so here all are my files, which is inside this project directory, and these all file by default comes under the working directory. Okay, I will show you the visualization of working directly, but you can now still remember visualize it as a working directory by default because these all our file can be edited or we can perform any operation on it, right? So we will try to track all the changes that we are doing in this particular file. Okay, so let's get started. First of all, let's move to this folder by this command cd desktop. So it is okay. We are already in desktop, so let's move into git demo. Okay. So now the very first command which we will using is git init, and it will initialize a .git folder inside your project repository, right? Means this git demo. So by default, this .git folder intentionally come in the hidden format, so you can't able to see. If you really want to see this folder, then you can just go to this, go to your project directory. You can see all these files which are basically comes under working directory, and here we have initialized this .git folder, right? So it's come in a hidden format. If you go and click view in Windows, and if you check on this hidden item, then only you will able to see. I have already on this, that's why it's showing right now. Okay, so the reason behind intentionally hiding this folder is if you do any uh, manipulation with this git folder, .git folder, will lead to the destruction or loss of all the changes that you have tracked, because every changes that you are tracking will be storing inside the .git folder, right? So be take care of that, because if you don't know much about it, don't go. Okay, so let's start with our next command, that is git add, right? First of all, let me show you one thing. Git status. Git status is also a very important command to know exact tracking of your particular code, right? Like if you go for the git status, you will able to know what is the condition of a file. See, right now when I have implemented this git status command, you can see git is showing that there are untrackable files. Okay, these all are the untrackable file, means git is not able to track those files, but it is there in the project directory. Okay, so to make this file trackable, to access to the git, we can use git add command and write a name of a particular file which we want to track. Okay, so just write index.html first file. So now if you type git status, then git is able to know, yeah, this is the file, and it is now moved from the working directory to staging area. I will show you all the visualization, how it's going, but till now you can see how these commands are working, right? And now if you go and this command get commit, which means that you are saving into a first version of a project, first commit, then it will store your save your changes, and it will be added in your first version of your project, very first version of your project, right? So we can do, okay, let's visualize what is happening, right? So when we hit get init command, so one new repository folder called .git folder is created automatically inside the repository, as you can see over here. Now you can visualize this repository project directory like this, that you are having inside your project directly, you are having working directory and a .git repository. So .git folder will store all the changes that you are making in your working directory, right? So it's really important. So simple visualization of .git repository. See, there are lots of mess inside a .git repository. So simply if you visualize this .git folder, it can be visualized like this. Inside the .git folder, also known as repository, there is a staging area and a commit history, right? So the staging area is an area where you are storing all the changes, right? All the files you are storing from working directory to the staging area. And the commit history is the area where you are saving those changes, right? If you save those changes, it will be counted as your version 1.0 of a particular project, and you can able to come even after a long period of time, you will able to see those changes. So when we hit git add command, so what it does, it take the all the file from the working directory that we are having and move it to the staging area, means into the repository. In staging area means all the changes that you have made are now trackable to the git, and it is now stored in the staging area. And you when go to the and hit enter with a git commit command, then it will be added in the commit history and make marked as a first version of your project, right? So overall working, you can see this is what happened. You have keep your project file inside the project directory. It's automatically by default comes under the working directory, and when you go for the git init command, it git add command, it will add it to the staging area, and then you commit it to make your first version, so it will go to the commit history. So this is what is happening. That's what I want to show you right now. So making multiple commits. Okay. So if I can visualize this, if you make a single commit, right? So what happen is, first of all, a recent commit is marked as a master, right? The commit which you make very recently will be marked as a master, and there is one more pointer which will show the active commit. Okay, so this is the first commit that you have done is marked as a master, and it is active, so head pointer is heading towards it. If you make more and more commit, right? If you go for the more and more commit, okay, git commit, it will form a parent-child relationship. As you can see, it is forming a parent-child relationship because we have done the first commit here, and then second, then third, then fourth, and this is the most recent one, right? And you can see this, as a unique number, which is provided to this commit, that is known as get unique SSH ID, which is generated by SSH algorithm. So if you see this in the action, let's make more commit. You go and again get add. Now let's add style.css and then commit it, right? Okay, let me use this commit. This will be our second commit. It's a message, you can give any message you want. I'm just giving so that you all can able to understand. So like this, we have completed with two commits. Let's make one more commit so that we can able to add .js file also. Get add team.js and commit it. So it will be our third commit. So till now we have done with three commits. To check how many commits we have did, we can use git log command and use one line so that you will be able to see not unique SSH ID. So you can see there are total of 3 commands, right? And head pointer is also heading towards the third command, which is the most recent command, and it's forming a branch, right? If you see, it is forming a branch. So this branch is known as master branch, and yeah, and that's it. So this is all about multiple commits. You can go for git add dot to add whole file. Now let's move to the next topic. I hope it is clear right now. So there's a topic called dissecting .git folder, right? So why to discuss this topic, right? If there is such a mess and .git folder is only storing all the changes inside it, what is the requirement to go inside and check what it is storing? So see, this session is not only about how commands are working and how it's behaving behind the scene. It's also all about how Git is working and how it's working behind the scene. So if you see, the one of the most important folder Git having is .git because it's storing all the changes. So one of the most important concept which is hidden with this .git folder is Git store each and every commit in the form of object, right? So every commit you make, it is stored in the form of object. So if you see a single commit, how a single commit look like, this is what a single commits look like. If you dissect a particular commit, when you are making commit, right, it will Git will first convert it into the Git object. Okay, so inside the commit object, which is also known as commit object, inside the commit object you are having tree, parent, author, committer, and a message that you are providing with that particular commit. Okay, so this is how they are storing your changes. See, inside Git, you if you see, it is stored in the form of key value pair. So inside we can see this tree part. This is tree is nothing but it is also an object, right? Let's come here. Now inside the object, Git is storing blobs. What is blobs? Blobs is also an object which is storing the content of your file. So this is how a single commit works, right? If you make any changes and make a commit, it's first converted into the object, then a tree object, then blobs. Blobs contain all the content of your file, and and this is how when you add all these, this is make your a single commit that you see on your CLI command line interface. Okay, so if you go and dissect it, let me show you. You go and dissect it by going into the .git folder. Let me show you .git folder first. So here you can see this, the .git folder. Let's go inside it. .git. Okay, if you go ls. So since it's a newly created repository, so there is not much mess. So you can see this object folder, right? See what happen is, first of all, when you make a commit, gets converted it into the object and stored into the object database. Here object database is nothing but this folder, object folder, right? So let's see how you can dissect a single commit, right? First of all, just go and hit git log to see what are the commits you are having. So these are the commits we are having. Let's dissect one. Let's dissect this second commit, right? So if we go and get show dash pretty is equal to raw, and then commit ID. So this is the commit ID which is generated. If you paste it here, so you can see right now, this is something known as dissecting it. Dissecting a single commit. Inside the single commit, you can able to visualize all these changes that has been stored in the form of key value pair. Okay, so this is commit object. So if you can see here, there is a part called tree, right? Inside the tree, blobs is stored. Let's dissect tree now. So for that, just go and have to go less list tree and a tree ID. Okay, yeah. So now we can see that inside the tree. we are having two blobs storing the file of index.html and style.css, right? So blob is where the content of your file is stored. So let's dissect the blob to see how your content are really stored, right? And then this blob ID. Yeah, so you can see all the changes that you have stored. So this is the value which you have stored inside the blob, right? So this is how we can visualize how a single commit looked like, right? So you can see it's having tree, then it's having blob, and inside the blob all the contents are stored. Okay, so let's come up. So we have done with this topic right now. Let's move to Git undoing. So remember in our high school we are having a whitener, right? Whitener, when we start writing with a pen, so we can use whitener to correct all the mistakes. So in Git also they provide the option of some making corrections. So the commands that provided by Git is checkout commit, revert commit, or reset commit. See, reset commit is something comes in the advanced option. So I will be not dealing this. This will be dealing the second session. So let's deal with the checkout and revert, right? So you can see how many commits we have made right now. Total three, right? Git log one line. So let's make this commit undo, right? Let's first of all, let's see how we can traverse in between commits, right? So if you go and hit get checkout, and then let's traverse back to the second commit. So yeah, we are now switched to this. As you can see, there is no JS file also, and JS file is only in the third commit. So we are now in the second commit. We are checking out the second commit. So this is how git checkout helps us to uh, help us to traverse between the commits, right? So let's move back to our first commit, most recent commit that is pointed by the head pointer. So we are moved, right? And now you can see here is also a JS file. So this is how git checkout works. And if you go and make any changes in the previous, it will also work for git undoing. And there is one more option of undoing thing, that is git revert. So what exactly git revert doing when we hit a command, when we execute that command is, when you make a commit, see these all are the commits which we have made. And if we want to change this particular commit, right? So we just go with git revert with the idea of a commit. And then what it does, it removes all the operations that you have performed in this particular git. Whatever thing you have added will be removed, whatever thing you have removed will be added. So it will be totally like a new one, and it will then send back to the forward, in the forward direction, the top direction, and marked as a head and master will be also pointing there to the recent commit. So if we see in this action, get revert, let's make second commit revert. So this is the idea of second commit. Okay, so it's giving me the option what message I want to keep. So I'll be keeping is at a revert second commit. Okay, so it's done. Now if you go and check that log line, you will be able to see that we have already removed all the changes that we have done in the second commit, right? See, in the second commit, we have added the CSS file. Now you can see it is removed, and uh, we are in the revert commit history, right? So now let's move forward. Was our next topic. So here it is. Git branching. Branching is considered to be the most powerful powerful feature of a Git, because it gives us the environment, a really isolated environment, so that we can work away from the master branch, and any changes that we are making in master branch will not be reflected. Any change that we are making in a branch will not be reflected to the master. So it's really help in collaborating when you work on a collaboration of projects, right? So let's see how to execute git, how to make a git branch. So if you run a command git branch, so you can see there is only one branch, that is master, right? That is by default. If you want to create a branch, you just go with this command git branch. Let's create a feature branch. This is our name of our branch. So your branch is created. If you want to verify this, just go and hit get branch again. So you can see there is a master branch and there is a feature branch as well. So if you want to traverse to feature branch, just use git checkout. Just check out feature. So now we are in the feature branch. So let's make some changes here. Let's say, all right, feature. Now let's commit it. So it's our first feature. So I will be writing on the first feature. And this is the command for executing both git add as well as git commit in the same time. So it will be creating a commit. You can see by using this log command. So you can see we have created a feature branch, and inside the feature branch we have created a commit with a commit ID 6GD, whatever it is. Let's make a few more. Oh, hello, bean committed. This is the second feature. Four commits, right? Three. This will be our third. Yeah. So if you see, so we are moved here. So as you can see, we have made three changes, three tags in the feature branch. And as I have said that it will not reflect to the master branch. So let's see what is it working or not. Let's check out to the master. So you can see it's already visible, invisible because it's in the feature branch, and we are in currently in the master branch, right? So the changes are completely invisible, vanished. So that's how Git provide a feature of working how working with branches. You can work isolatedly in a different environment, and those changes will never reflect here unless and until you do merge. Will we see that topic also? So let's see what else we can do with branching. We can also add tags. Let me show you that. The tags are helpful when you are working on a really big project, so that you will able to define a particular single commit as a tag, so that you able to know, yeah, this is the version one. So let's see how it works. Git tag version 1.0, this commit. Let's see this commit of the master branch. So if you go and check out again, so it will be marked as a version 1.0. So if you see from first commit to second, okay, revert second commit, it's version 1.0 of your project. So this is how it's helped, so that everything doesn't get messed up. So it is also really helpful. And you can also delete it. When you can also delete this tag if you don't want it. Get minus t and name of that version that you have added. Okay, showing something else. Yeah. So tag was deleted. You can just verify with this. There's no tag. So how to differentiate between the two branch, right? If you want to differentiate between the two branches, right now we are having the branch, if you can see, we are having two branches. So how can check what are the changes that we have did in the feature branch? So for that we are having one more command called get def master double colon. So you can see these all are the tags which we have added. So it's really helpful when you want to see what is there in the feature branch before merging. Okay, if you want to delete delete a branch, you can go with get brand branch minus d and the name of the branch. Brand get deleted. You can see in this by using get branch. So yeah, feature branch has been removed, and we are in the master branch. We are left with the master branch only. So this is how Git branching works. These all are the basics of Git branching. Now let's move to Git merging, right? So merging is also a very important tool, that important feature that Git has provided, because if you are doing working in the branch, then you need to merge those branches, right? So if you merge those branch, you are just contributing to the master branch, and those feature will be added and marked as your first commit, right? If you see here, I create git branch feature. Now feature has been created. Get checkout feature. Now make some commit. So these all are the commits which is adding in the feature branch, right? And then if we master, you can see we have created two branches, right? From here to here it is master, and then it's a feature branch, right? So what I'm talking about merging, right? So merging are basically of two types: fast forward merge and three-way merge, right? When you are making changes in the master branch, and then you have created one more branch and start making changes in this feature branch, and then you haven't go again to the master branch to make some commit and merge those commit, then it will create a fast forward merge. Let me show you the real example, how it can be visualized. So like this, we have two branches, master and feature. Now if you want to merge those without going back to the master branch, then we can do it like this: merge. So this is what called fast forward merge. I haven't traversed back to the master branch. I have just made a feature branch and make more and more commits, and then merge both the branch. So this is something called as fast forward merge, and it's very rare, right? If you are working on your project and no one is collaborating with that project, then you can see this for fast forward merge. And by default we are having a three-way merge, because if you go to the big organization, everyone is contributing to that project, so there are a lot of commits in every branch, so it will always a three-way merge. And one more point, that three-way merge also have a strong disadvantage of merge conflict. It's not a disadvantage, it's an event, right? So merge conflict, I will show you first. Let me show you it in the folder, right? I'll clear all this, and let's move to the I have one more folder called git merge. So there we will be seeing how git merge works. Let's get inside it. Merge. Yeah. So I've already made many branches inside it. So let's see what are the branches. Okay. So we are having two branches, feature and master, right? Then let's see what are the changes I have done. So these all are the commits that I have made it. Total of I don't know how much. Okay. So let's try to merge this, right? This master branch and this feature branch. Let's try to merge this uh, by using git merge. We try git merge. For merging, you should be in the master branch. So let's go back to the master. Already up to date. Okay, 1 minute. Okay. You are merging a feature branch. Okay, this is wrong. Yeah. So this is what happened. A fast forward merge, right? It's also mentioned over there. It's a fast forward merge, right? So this is how a fast forward merge looks like. Because I haven't committed anything in the master branch, I just merged both the commits. So if you want to see for three-way merge, just go to the git, check out feature, and make some changes over here. If we go and change this tag and make it as feature, save it, and then move back to the master branch. Okay, commit it now. So it's okay. Now we move back to the master branch. Right, in git commit. Okay, let's some make some changes in this. Okay, we can add 4 change 4 3 and then commit it. Now let's merge both. Yeah, so this is something called as three-way merge, right? As you can see here also showing that it's auto merging by recursive strategy, right? So this is something called as something we have did with three-way merge. Now let's come to the merge conflict. See, merge conflict is an event which occur when you are changing the same line of code. You are making changes in the same line of code. So basically, merge conflict occur while merging a branch, while rebasing a branch, and cherry picking a branch, right? So what happens is when you are merging two commits and the changes are made in two different lines, it will be merged perfectly. If you are making changes in the same line, as you can see in this commit A, we are making changes in the second line, and also in commit B we are making changes in the second line. Then when we try to merge, it creates a conflict because Git unable to understand which code to keep and which line to keep or which line to delete. So there he throws that decision to user. That user has to decide there which command to keep and which to not. And then after when user decided that how which particular code should be there, then it will merge successfully. This is how merge conflict resolves. Okay, so let's see this in action. We are in the master branch, so let's remove these two lines. 1 minute. Okay, let's remove these two lines. Add h1 tag, save conflict. Okay, so we have 1 minute. So we are making changes in two lines, that is 15, 16. Remember this. Conflict and commit this change. Now go to the feature branch. Now make changes in these line only. Now, hello. Okay. So now commit this change. Now let's move back to master. And now let's merge feature branch. See, so this is what I'm talking about. This is something known as merge conflict, right? We have made changes in 15 and 16 line, and in feature branch also we have made changes in the 15th and the 16th line. Therefore, while merging, it conflicts. So to resolve this conflict, you just go and remove all these comments, right, from here. And this one. Now we can able to merge this file. For doing that, just commit it. Merged file. And yeah, so this has successfully merged. You can see by using git log one. Yeah, so we have merged these two files and solved the merged conflict, right? So after that, we are having merged undo merge. Okay. So this is very similar to git revert what we have did right now in the command. Actually, what happens when you merge something, it will make a new commit over here. Now, if you don't want this commit, you just go and hit with a command git revert and this ID. It will create again a new commit and remove all the merging which has been done over here. So this is how undo merge work. This is similar to how I have shown the git revert. So I will not show this. So SSH authentication. So let me read this. SSH authentication means, see, SSH is basically a protocol, right? Like HTTP, it's also a protocol which provided a secure connection between the client and a server, right? So basically, if you don't use SSH, by default, Git provides you with the HTTP authentication. When you try to push the code to the GitHub, right? So it will always ask you a password. So if you use SSH, the benefit is that you don't need to give any password at all. You first you generate a key, you generate a secure connection between your because you are telling that, right? You are telling to Git, yeah, I am this particular local computer is authenticated for using this GitHub account. So for that we use SSH authentication, right? So let's see how it's work. Connecting to GitHub by SSH. See, for using SSH authentication between Git and GitHub, first we have to generate SSH key, upload a public key to the GitHub, deploy SSH agent, then connection will be established. So we'll be seeing each step one by one. First, generating SSH key. See, key is basically nothing but it can be generated when we through CLI. So what key does is we store a private key and a public key. Private key we stored in the client server, client, and public key is basically stored in a server. That is, in our case, is Git. So when we verify those key that this private key has generated this public key, your connection is established and you can able to push the code because authentication is already done. Right? Let's see this in action. Let's try to push this particular repository into the Git, right? So for that, we don't want to generate SSH key over here. Just move back, come out from your repository. And for generating SSH key, we can use these following commands. First of all, we will be establishing keygen. Okay, so we are now creating a SSH key. So for that, here you have to provide the type of encryption. Then you are having the strength of encryption 4096. And then you will provide associated Gmail account with a GitHub over here. So now it is generating that key. You can name your key here. I am naming it as a G key, GitHub key. Okay, it key is already exist. Okay, overwrite. And yeah, your key has been generated. If you really want to see your key, just use this following command and name of your key. So as you can see, we are having G key, which is a private key, and one more key that is a public key. So these two are the keys which we have to upload. One is already inside our local computer, one we have to upload in the GitHub. So let's see how it's look like. If you go and check with cat G key, it will G key. It will show you the whole key. It's really a mess. And let's see how our public will look like. PUB. Okay, so this is how our public key look like, and this we have to upload in the GitHub because this is and then we have to verify that this private key, right, has generated this public key. So we will upload this, but first of all, let's see what is the yeah step two is this. So it's slow. That is slow. Let's see the next step. Let's reload this page. So basically, we have to authenticate that this private key has been generated by this public key, right? So for doing that, there comes up a SSH agent, which is responsible. This is a program which is responsible for verifying that, yeah, this private key has generated this public key. And when it's done, you can push your code without any password or anything authentication because authentication has already been completed by SSH agent. So let's deploy one SSH agent. For doing that, you can use eval agent. Okay, so it's set up. SSH agent has been created. Now let's deploy it to the specific path where our private key has been located. Right. For that, you need to provide the path, and you can see its path is something called .ssh/id underscore RSA. slash id rsa and done. Okay, identity has been added here. Now we only need to upload this code to the GitHub. You can go to the settings and then SSH key and GPS. Okay, we are already having. Let me delete this. Add a new SSH. Paste it here. Name anything and add SSH. It's asking for a confirm password. So your SSH key has been added, right? Now you can push this code, the whole code. First of all, let's get inside the repository. Then hit demo. Once check the status. Nothing to commit. Yeah, we are ready to push. Okay, so we are here. We have deployed the SSH agent and now we are pushing code to the GitHub, right? So first of all, we will add a origin, right? So when we are pushing something in a Git, you first need to make a repository on Git where you want it to push. Then copy the link of that repository. Let me show you. This is new repository. It's taking a few time. New repo. Just create it and copy this repo link. And now you can just able to push, right? By using this command get remote add origin, and then you can paste the link. We are adding a origin where we have to put, right? So check the origin. What is your origin? You can use this command get remote sv, and yeah, it is our yeah, this is only the link which we have copied from GitHub. Now you are ready to push, right? So the third step, now to push the code into the GitHub, you can use this command, right? Get push master origin. Push. If there is something. Okay, there is something mistake. One minute.
It would be Origin Master, I believe.
Okay, yeah. Sorry. Okay, yeah. So it is, yeah. So now it is pushed. So you can check it out. So it is there, right? Mm. So yeah. Thanks guys for joining this session. This is the last slide. So we have completed. So really thanks for joining. You can attend for advanced session on Git after this. So yeah, we have completed.
Hey, thanks, Aman. It was really